Okay, so let's have another example of the principle of mathematical induction. Suppose that you will prove the statement 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 is equal to n squared. Now we will show that the left side of this equation is equal to the right side. So again, our proof starts with, for all n greater than or equal to 1, let p sub n be the statement, okay, be the statement 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 equals n squared. Let's start with the base case. We show that p sub 1 is true. Okay, so our p sub 1 in this statement or in this sequence is 1. We will equate that to the right side of the equation, which is n squared equals n squared. Now here, p sub 1, now it came from p sub n, diba? Our p sub n to p sub 1, so n is equal to 1, ana, huh? So we will substitute 1 to n. Copy sa left side 1. Now n is 1, so we have 1 times 1, that is also 1. Thus p sub 1 is true. Now let's go to the inductive case, the second part. Okay, so let k be greater than or equal to 1. Alright, k be greater than or equal to 1 and p sub k holds. So we show that p sub k plus 1 is also true. Now that is let's copy. So from n mahimo na si k, diba? Ang kaning atong equation diri a or sentence statement diri a, lista na to si n ng k. So we will have 1 plus 3 plus 5 plus from n, mahimo na ng k, 2k minus 1 equals from n squared, that becomes k squared. No, so next, copy the whole sentence here, the whole statement on the left side. 1 plus 3 plus 5 plus dot 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 plus 2k, alright, plus 2k minus 1. Now, di ba we wanted to show that p sub k plus 1 is also true. So, magdugang kita dariya ng k plus 1. Ang last term sa imong sequence sa left side, imong i-add, but si k mahimo na ng k plus 1. Okay? From here, 2, copy si 2 here, and then k becomes k plus 1. Times k plus 1 minus 1 equals, alright, equals, what's next? K plus 1 squared, no? So from k here, nahimo na ng k plus 1. Copy ra ang exponent. Now here, we all know, diba, na nag-claim kita that this statement, kaning statement maura man ni siya, diba? We assume that this statement is equal to the right side. So we can replace k squared to this. No, this whole statement that becomes k squared, no? Plus 2 times k plus 1 minus 1 equals k plus 1 squared. Next, copy na to si k squared. K squared plus distribute 2 times k, 2k. 2 times 1, that is 2. Minus 1. Okay? Minus 1. While on the right side, k plus 1 squared. So, ato na i-simplify. Diba si k plus 1 squared is just equal to k plus 1 times k plus 1. Diba? Or you can also have it here. K plus 1 times k plus 1. K squared plus k plus 1. So we're left with k squared plus 2k plus 1. Okay? We have k squared plus 2k plus 1. Or ato anay ikuan. Buyago na to. Factor ato iingana. K plus 1 i-breakdown na to times k plus 1. Now, on the left side, here, we combine the like terms. So, k squared plus 2k, alright, and then plus 2 minus 1, that is just equal to 1. Now, here, on the right side, k plus 1 times k plus 1, the answer is k squared plus 2k plus 1, no? K squared plus 2k plus 1. So we found out that the left side, right, the left side is equal to the right side, no? Thus, therefore, p sub k plus 1 is true, no? Thus, p sub n is true for all n greater than or equal to 1. Alright, end of proof.